Okay, today we're going to see how to derive quadratic formula using completing the square method. But before proceeding, I'd like to explain what quadratic equations are. A quadratic equation is an equation which the highest degree of the unknown variable is 2. So this is a quadratic equation. Why? Because highest degree of the unknown variable x is 2. So given this quadratic equation ax squared plus bx plus c to be equal to 0, we want to derive the quadratic formula using completing the square method. Step 1. Subtract the constant from both sides. In this case, the constant is c because it doesn't have a variable. So we subtract the constant from both sides. We have ax squared plus bx plus c minus c is equal to 0 and c. That eventually gives us ax squared plus bx to be equal to minus c. Step 2, we divide through by the coefficient of x squared. In this case, the coefficient of x squared is a. So we have ax squared over a plus bx over a to give us minus c over a. And a cancels a, leaving us with x squared plus bx over a to be equal to minus c over a. Now, step 3. Add half of the square of the coefficient of x to both sides. The coefficient of x is b over a. So half of b over a gives b over 2a. Now the square of b over 2a is b over 2a all squared. Have to consider the sign in front of it. In this case, we have plus. So we had x squared plus bx over a to give minus c over a, which now becomes x squared plus bx over a plus half of the coefficient of x, which is plus b over 2a, all squared to equal to minus c over a plus b over 2a all squared. Step 3, step 4. Step 4, factorize the left hand side. So we have x squared plus bx over a plus b over 2a all squared to give minus c over a plus b over 2a all squared. And we factorize this, the left hand side factorize to give x plus b over 2a all squared, which is equal to minus c over a plus b over 2a all squared. Step 4, we evaluate the right hand side. We have x plus b over 2a to be equal to minus c over a plus, now let's square b. So we have b squared over the square of 2a is 4a squared. So we have x plus b over 2a all squared to give, now the LCM of a and 4a squared is 4a squared. So 4a squared divided by a gives 4a. So 4a times minus c gives minus 4ac plus 4a squared divided by 4a squared is 1. 1 times b squared is b squared. So we have x plus b over 2a all squared. We now rearrange so that plus comes before minus. So we have b squared minus 4a over 4a squared. The next thing we need to do, we have to take the square root of both sides because we need to get value for x. So we have the square root of x plus b over a all squared to give the square root plus or minus b squared minus 4ac over 4a squared. Now, it's not possible for us to get square root of our numerator in this case, but we can get the square root of the denominator because the denominator is a perfect square. So we have x plus b over 2a to give minus plus or minus b squared minus 4ac over 2a. We were unable to get the square root of the numerator because it's not a perfect square, but we could get the square root of the denominator. So we have x plus b over 2a to give plus or minus square root b squared minus 4ac all over. Now the square root of all a squared is 2a. So x is now equal to, we now move this one to b over a to the right hand side. When it crosses, this positive sign changes to negative. So we have minus b over 2a plus or minus square root of b squared minus 4ac over 2a. Since our else the denominators are the same, so we have x equal to minus plus or minus b squared x. Since the denominators are the same, we have x to be equal to minus plus or minus the square root of b squared minus 4ac over 2a. That is how we write the quadratic formula.